The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hi, and welcome to Skeptically Speaking. I'm Marie-Claire Shanahan, guest host today for Desiree Shell. I'm really pleased to be joined by David Quammen, author of Spillover, Animal Infections and the Next Human Pandemic. He's a contributing writer for National Geographic and has also written for Harper's, The Atlantic, Esquire, and the one that caught my personal attention, Powder, the skiers magazine. David is a dedicated reporter who travels the world to immerse himself in the work and lives of those he writes about. Welcome, David. It's a great pleasure to speak with you today.
Thanks, Marie-Claire. It's good to be with you.
So let's talk about your current project, which is the book Spillover. What brought you to, which is probably a topic that's a little more challenging than mountain peaks and snow?
Well, I spent a lot of time in jungles, too. And I was in Central Africa back in July of 2000 for National Geographic, covering a cross-Congo transect, a survey hike through the last remaining great forests of Central Africa. And in the middle of one of those forests, I was sitting at a campfire with a couple of local guys, and they started talking about Ebola virus, the time Ebola struck their village. They told me this whole story of how horrifying it had been, loved ones and friends dying of this terrible virus. And then one fellow mentioned, strange thing, at the same time there was something peculiar we saw. Nearby in the forest, a pile of 13 dead gorillas. I mentioned this in the book. I explained this a little bit. I knew already a bit about Ebola, and one of the things I knew is that it afflicts apes as well as humans. It kills chimps and gorillas. So when these guys mentioned 13 dead gorillas in the forest near their Ebola-stricken village, I knew that the logical inference was that Ebola had killed those gorillas too. A little bit more research showed me that that forest was great gorilla habitat, but it was empty of gorillas. They had presumably been killed in a wave of Ebola sweeping through that particular forest in northeastern Gabon. So this, as I say, was back in July of 2000. I never got that image. I never got that phrase out of my head, 13 dead gorillas in a pile. About 6 or 7 years later, it became a book project for me. It became the beginning, the first thread of this journey into the world of zoonotic diseases.
So the term spillover in particular refers to the relationship that a disease has between the animal host and human host. Can you help us define that a little bit?
Spillover is the event, the moment when a disease pathogen passes from one species into another. From our point of view, that's generally talking about zoonotic diseases. It means it's the moment when the virus or the bacterium or whatever the pathogen is, when it passes from the non-human host into the first human victim. And then it either is or is not transmissible from human to human. It might result in an outbreak, might result in an epidemic, might even result in a pandemic. But that first step from the non-human host into the first human, that's the moment of spillover.
So we're talking almost on an individual level that moment happens.
Yes. But of course, the spillover can happen numerous times. Ebola has spilled over into humans, 15 times in the last 30 years that we know about. And each of those caused an outbreak. None of those, fortunately, caused an epidemic or a pandemic. With influenza, we know that the new bird flu that's killing people in China has spilled over directly from birds into humans. It seems about 30 times that the Chinese authorities know of. They've got 30 confirmed cases. 9 of those have been fatalities.
Really, you're talking about a lot of different, you've mentioned that it's both viruses and bacteria, that these things happen sometimes repeatedly with different pathogens. What is it that makes something zoonotic or not zoonotic?
A zoonotic disease is easy to define. It's a zoonosis is an animal infection that's transmissible to humans. It might be a virus, might be a bacterium, might be a worm, might be a prion or a fungus. And when it spills from a non-human host into a human, then it becomes a zoonosis. If it causes disease in us, which it doesn't always do, but if it does, then it's a zoonotic disease, if it causes symptoms and illness.
One of the examples I found really interesting in the book was malaria. And you described that its status had kind of changed in relation to zoonosis.
About 7 years ago, National Geographic asked me to do a feature story on this subject, on zoonotic diseases. And that was sort of the beginning of what became the book project. But I did the feature. It ran in Geographic in, I think, 2006 under the title Deadly Contact, I believe. And when I was researching that piece, the experts that I talked to told me, well, if you're doing zoonotic diseases, then that means, West Nile and the influenzas and Ebola and a number of others, rabies, Lyme disease, but it does not include malaria, because malaria is caused by 4 different kinds of protist, protozoan, as we used to call them, 4 different kinds of bug, and all of those are unique to humans. They're vectored by mosquitoes, passed from human to human by mosquitoes. The 4 different kinds of malaria parasite that we know of, Plasmodium vivax, Plasmodium falciparum, etc., those bugs infect only humans. They're vectored by mosquitoes, but in terms of causing disease, they cause it only in humans. I was told you'll want to leave malaria off your list because it's not a zoonotic disease. And then as I was researching the book, I got into this a little bit more deeply, and I noticed that there is now a 5th kind of malarial parasite, malaria-causing protists known. It's called Plasmodium knowlesi, and it is genuinely zoonotic in that mosquitoes carry it back and forth, not just among humans, but between humans and non-human primates. This is on the island of Borneo and in peninsular Malaysia, Plasmodium knowlesi, carried by mosquitoes between long-tailed macaques and humans, and 1 or 2 other species of macaque and humans. So it's a genuinely zoonotic form of malaria, and I write about that particular case in the book.
You mentioned that there's 4 human forms of malaria. There are other forms of malaria that already afflict other primates. Is that right?
Well, there's a whole large genus of them, all within the genus Plasmodium. There are some that specializes in infecting birds, some infect chimps, some gorillas, and I talk in my chapter on this in Spillover about the work that's been done by a number of scientists trying to identify the original sources of human malaria. That chapter is entitled Everything Comes from Somewhere, and the point I'm making is that these virtually all, or it's probably even safe to say all, human infectious diseases come originally from other species, from non-human species. We know that 60% of human infectious diseases are presently zoonotic in that they have spilled over from non-human animals into humans, and they continue, in some cases, spilling over from non-human animals into humans. That's 60%. But where do the other 40% of human infectious diseases come from? As I say in my title, everything comes from somewhere, and those other presently non-zoonotic diseases, infectious diseases of humans, virtually have to have non-human animal origins because we're a relatively young species and our diseases have to come from somewhere. So things like measles and polio, viruses that are presently known to infect only humans, seem to be descended from zoonotic viruses that we originally got from non-human animals.
That's really interesting in the way that you describe how much more complicated it really is. What are some of the kinds of evidence, actually, that we can look for to try and figure out where those things that aren't presently zoonotic, where those came from?
The best and the most persuasive form of evidence is molecular phylogenetics. People now are able to sequence the genomes of viruses and bacteria fairly quickly and reasonably cheaply. So you can look at a virus and say, what's it related to? Enter it into a database and compare it to other known viruses. You might be able to tell from those old-fashioned methods what group of viruses a new virus belongs to. But in terms of finding out exactly what its closest relative is, the scientists are now able to sequence the genome of a virus or a new bacterium and say, well, what does it look most like? So, for instance, when a new virus that was given the name Nipah emerged in peninsular Malaysia back in 1998 and 99, scientists were able to sequence the genome and say, well, it is a paramyxovirus, but what's it most closely related to? It's most closely related to this thing called Hendra that emerged just a few years earlier in Australia. Both of them are horrific zoonotic viruses. Nipah virus found to have its reservoir in bats, spill out of bats, get into pigs, be amplified in pigs, and then kill humans. And Hendra virus in Australia has a somewhat different story. It spilled out of bats, got into racehorses, killed racehorses in very ugly ways, and then got into racehorse trainers and stable workers and veterinarians and killed some of them. So the molecular phylogenetics, sequencing the genome and comparing it to other things, is how we know, for instance, to place those very new viruses in a broader context of what they're related to.
You're listening to Skeptically Speaking. I'm here with David Quammen, author of Spillover, Animal Infections and the Next Human Pandemic. I kind of wanted to describe this to someone else, actually, as a really intensely reported book. Is that a fair description?
I'm delighted to accept that description, as it certainly felt very intense to me at the time. When I research a nonfiction book, a book about science, I tend to combine a lot of talking with scientists, interviewing scientists, reading of stacks and stacks of journal papers. I combine that with field time. I like to get out in the field with scientists and experience some of the conditions and some of the things that they're seeing as they do the research. And in this case, the book is about the ecology and evolutionary biology of scary viruses as much as laboratory and clinical understandings of how those viruses affect humans. So whenever possible, I went with scientists into the field, into Bangladesh, into Malaysia, into the caves of southern China, into the forests of the Congo, to see what they were doing, see how they were trying to learn about the ecology and the dynamics of the spilling over of these scary pathogens.
So why do you think that this particular topic, you mentioned kind of the scariness involved, but why does it need that kind of really deep attention?
Every zoonotic disease starts as a mystery story. And that's one of the things that's wonderful as well as scary and horrifying about the subject. When a new disease breaks out in the human population and people suddenly are dying in the racing industry in Australia, or they're dying in the pork industry in Malaysia, it's a mystery story, and scientists come in and they try and control that outbreak, but they also try and solve the mystery. They try and learn, what is this new virus? How can we characterize it? What is it related to? But equally important, where does it come from? What's its reservoir host? The reservoir host is the animal or plant in which the zoonotic virus lives inconspicuously without causing symptoms until it gets into humans. So they want to know, what's the reservoir host and what are the dynamics of it suddenly entering human populations? What's causing the spillover? What kind of interactions with the reservoir host are causing humans to be exposed and to become infected with this? It's both scary to people because it involves gruesome forms of illness and death, and it's, I think, a compelling subject in terms of people's to read about a mystery and see it solved and see the heroic effort that's put into this by the scientists who study these particular mysteries. These are the disease detectives who go into the remotest parts of the earth and study some of the scariest pathogens. What's not to like about reading about them?
They're really compelling. I have to say, I didn't expect this to be something that I walked away with a good sense of these wonderful characters, in a sense. I mean, they're real people, but they're really vivid in your accounts.
It's a sober subject. It's an urgent subject. There's a lot of important information involved, but I did not intend this book merely to be an informative duty for people to read. I wanted this book to be a guilty pleasure. So I've tried very hard to fill it with adventure and danger and wonderful human characters and storytelling, as well as a lot of intricate scientific information, because I want it to be a page turner.
Yeah, I think it is.
Thank you very much.
Are there any of those characters that really stood out that when you were there, you thought this is going to be such a vivid account? Something I can really tell a great story about?
I think of John Epstein, wonderful scientist who works for EcoHealth Alliance, who studies Nipah virus in Bangladesh and elsewhere. And I describe in one of my chapters spending time with him in Bangladesh as he's trapping giant fruit bats to take blood and fecal and saliva samples from these giant fruit bats to test for this terrifying and dangerous virus, Nipah virus. And in order to do that, we're suiting up in coveralls and Tyvek suits. We're wearing high-quality respirator masks and goggles. Then we're climbing a rickety ladder onto the top of a deserted warehouse in Bangladesh in the middle of the night, where he and his team have rigged huge mist nets to trap these bats as they come back from their nightly feeding. And of course, if you're wearing a respirator mask and goggles in a tropical place, what immediately happens is that your goggles fog up and you can't see. So I'm climbing this ladder onto this warehouse roof. My goggles are fogging up. It's the middle of the night. We're looking for a lethal virus and the bats that carry it. And I'm thinking, boy, I love my work. But I'm glad that John is the one who's going to be handling these bats, and I'm going to be standing 3 or 4 feet behind him with my hands, insofar as I'm allowed, tucked behind my back so that he won't hand me one of these things in the heat of battle and expect me to hang on to it.
That sounds like a pretty reasonable reaction.
People have asked me, don't you get scared going into these places? And I suppose I should maybe be scared, but the more I learn about these viruses and the people who study them, the more my irrational fears turned into rational precaution. My policy was to wear whatever sort of personal protective equipment the scientists were wearing, trust them, trust their professionalism, and stand 4 feet behind them.
That seems like a good plan. And I would say that as we were saying, some of these details did really resonate. And one in particular for me was when you were talking about SARS, which hit Toronto in 2003, amongst other places. But I was living in Toronto at the time, and I remember the news reports, and I remember the sort of change from talking about this atypical pneumonia to kind of giving it a name and trying to figure out where it was coming from, what it really was, and the fear that went along with that. From a zoonosis perspective, these kind of one-time flare-ups of things like SARS that we really haven't heard about since, are they interesting beyond just telling the story of what happened at a particular time and place?
The answer is yes, interesting and important. SARS, as you say, was an enormously dramatic, spooky, scary outbreak at the time. Here was a virus never known before. Suddenly it's killing people in southern China and then in Hong Kong. It is passed by the respiratory route so that it's causing these various kinds of horrible symptoms, but one of them is coughing. Severe respiratory problems that result in coughing and choking. Patients were being intubated in hospitals, tubes put down their air pipes so that they could survive. And in the process of intubating them, healthcare workers were getting big doses of this virus and they were becoming infected. And then there was a 78-year-old grandmother, as I recall. I think she must have been, she's not identified because of the sort of the medical confidentiality, but I think she was probably a Chinese-Canadian person who got on a plane, went to Hong Kong to visit relatives, got infected in a particular hotel, on the 9th floor of which this bug was being spread. And then she got on a plane and came back to Toronto and infected her son. And then her son died and she died. And that's what apparently began the outbreak in Toronto. This virus, the SARS coronavirus, they call it, is enormously dangerous, has a high case fatality rate, is extremely contagious by the respiratory route, and yet they stopped it. Some people think, well, SARS died out in 2003. It infected about 8,000 people, killed about nearly 800, but it did not die out. It was stopped by fast and very efficient and stringent healthcare measures and fast diagnostic science. It was a worst case scare, but a best case scenario in terms of control of a potential pandemic disaster in our recent history. We haven't seen SARS since 2003. Why not? Because it's gone from the planet? No, it's presumably still living in bats in southern China, but it has not spilled over into humans and spread into a new outbreak again since 2003. That could happen again. The same thing with the influenzas, but those happen much more frequently.
So in as much as it's possible, SARS is kind of a good news story?
It's a cautionary tale. The experts that I talked to about the question of where will the next big one come from and what will it look like, one of the things they mentioned is that, well, we should watch out for another coronavirus because SARS was so dangerous. We were lucky and we were good to have stopped it in 2003. SARS could come again, or something SARS-like from the same group of viruses, the coronaviruses, could come again. And that's why you may have noticed that beginning last summer, there was some word about a novel coronavirus that had spilled over in Saudi Arabia, caused about 5 or 6 cases in people on the Arabian Peninsula. Some of them were eventually hospitalized in London. and it killed a high percentage of the people that it infected. It was a very, very tiny thing. It only infected a few people, but disease scientists all over the world watched it very carefully. Why? Because of that word coronavirus, and because they knew from 2003 that the experts had been warning us, watch for another coronavirus. Here was another coronavirus, so they've been monitoring that very carefully.
We'll be right back to chat more about the history, pathology, and impacts of zoonotic disease.
Skeptically Speaking is rebroadcast on a number of fine radio stations. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
Welcome back to Skeptically Speaking. I'm guest host Marie-Claire Shanahan, here today for Desiree Schell. I'm speaking with David Quammen, author of Spillover, Animal Infections and the Next Human Pandemic. He's a contributing writer for National Geographic and was a 2012 recipient of the Society for the Study of Evolution's Stephen Jay Gould Prize for exemplary efforts to advance public understanding of evolutionary sciences. So we were just talking about SARS and how, in a sense, a lot of these examples do have kind of personal resonance for people. They grab particular moments in time, and you've been really vivid with them. You've mentioned bats a couple of times already. That piece kind of jumped out for me as well. I grew up on a farm. Bats were not uncommon, and I've never been personally particularly fussed by them. I'm starting to change my mind based on what you've written about bats. Am I justified possibly in that?
Well, yes. A number of these, the viruses in particular, a number of these new, scary, dangerous viruses have their reservoir hosts in bats. Bats are the creatures in which they live permanently, inconspicuously, apparently without causing symptoms, and from which they spill over into humans. We know there's some common association between rabies and bats. We know that Hendra virus in Australia has its reservoir in bats. Nipah virus in Malaysia and Bangladesh has its reservoir in bats. Australian bat Lissa virus, which is related to rabies. Marburg virus, we know now, has its reservoir in bats. Marburg is closely related to Ebola. We don't know the reservoir of Ebola, but bats are high on the list of suspects. And then there's a number of others. There's a whole litany of these things that have their reservoirs in bats, so that the scientists have begun asking, why bats? Is it a real pattern, or is it just an artifact of the fact that bats are a very, very diverse order of mammals? In fact, 1 in every 4 species of mammal on the planet is a bat. So it may just seem that bats are overrepresented because they're overrepresented in the diversity of mammals. But it's also very possible that bats actually are overrepresented. And there are some scientists like Charlie Kalischer in Colorado, a wonderful virologist, and others who have written papers and examined this question, why bats? And I go into that in one of my chapters in the book, the pattern of bat implication and the reasons why bats may be overrepresented. Having said all that, it's really important for people not to demonize bats. Bats already have a PR problem, we know that. And if bats are carrying more viruses that potentially can infect humans, then the answer, of course, is not to kill all the bats. The answer is to stay the hell away from the bats so that we interact with them in ways that cause us to become infected.
Yeah, let them live their lives, I guess. You mentioned as well that there are several kind of new emergent spillovers from bats, that there's a possibility, it seems like those opportunities for those spillovers are maybe increasing. What kind of conditions, bat living conditions, could possibly be contributing to that?
First of all, in terms of bat living conditions, bat population biology and ecology, some of the factors that might actually contribute to them carrying more than their share of viruses and potentially human infecting viruses are the fact that bats, for relatively small-bodied mammals, they live long lifespans. Bats might live up to 18 or 20 years in the wild. They also live in very dense aggregations. They roost in huge groups or colonies together in trees or in caves where they're cuddled together 4 and 5 deep. They're in very close contact with one another. And therefore, the combination of those things, longevity and very, very dense sociality, suggest possible factors that could be nurturing to viruses.
And we're having an impact on them as well, is that right? Kind of changing some of their habitats or some of their patterns?
We are having an impact on them, yeah. Bats are hunted for food, especially big fruit bats are hunted for food in Africa and in southern Asia. People go into these giant bat roosts in trees with shotguns, killing bats, taking bats to market, cooking and eating bats. And if any activity is calculated to give a virus the opportunity to spill over from its reservoir host into a new host, namely humans, then it's that kind of activity. It's the ecological disruption of bats in their native habitats that offer the opportunity for the viruses to spill over into humans.
I mean, chances are, at the moment, it seems like we're actually part of that issue as well.
And there's also, it's not just people hunting bats for food. Deforestation in Australia, deforestation in peninsular Malaysia have displaced some of these big populations of giant fruit bats from their native habitat. Under ordinary circumstances, they would live in forests, they would eat fruit, they would eat blossoms, they would drink nectar. When the native forests are cut down, either in Australia or, say, in peninsular Malaysia, then those bat populations are displaced and they go looking for alternatives. In Australia, giant fruit bats of the genus Pteropus have been moving more into cities, roosting in the parks of even in Sydney. They have been going to orchards in Queensland. They've been coming closer to humans because humans have been destroying their native forests. In peninsular Malaysia, destruction of the forests have pushed bats into, or they did in the late 90s, they pushed bats into areas where fruit trees were planted in conjunction with large pig farms. And it was the juxtaposition of the fruit trees, mango trees and others, with the large pig farms, in some cases mango trees even overhanging, shading the pigsties, that brought the bats together with the pigs that allowed Nipah virus to spill out of bats, get into pigs, be amplified, and then kill more than 100 pig farmers.
So it's a complicated dynamic for sure. You've mentioned most of the things that we've been talking about, I think, except maybe malaria so far, are viruses. And I think that's typically what most of us think about when we think of zoonotic disease. Most of probably the contagion-style movies are usually about viruses as well. What's the role of bacteria in zoonotic disease?
Well, bacteria is there too. It's a little easier for us to deal with bacteria now because of antibiotics, but that doesn't mean they don't continue to be part of this situation. For instance, Lyme disease is a zoonotic disease caused by a very tricky and problematic bacterium. It's a spirochete. It is, in some cases, seems to be resistant to antibiotics. A lot of people in the U.S., probably in Canada also, at least eastern Canada, have been infected with Lyme disease. It is vectored by ticks. It's hosted in mammals, mice and deer, and carried from the mice and the deer to humans by ticks, but it is a bacterium. It still manages to cause a lot of illness, probably not any or much death, but a lot of real morbidity, misery, and illness in a lot of people in North America.
And the only sort of benefit of bacteria is they are a little easier to spot, is that right?
They're easier to spot. In some cases, they're easier to deal with by way of antibiotics. For instance, bubonic plague is also caused by a bacterium. Bubonic plague was, of course, a horrible, horrible disease in 14th century Europe. Now, it still exists. There's bubonic plague in rodents in the southwestern U.S., but we don't hear much about it. It's not a terrible problem because the plague bacterium can be dealt with by way of antibiotics.
What I was wondering is why some bacteria, you said they're a little easier to spot, sometimes they're easier to treat with antibiotics, but why there are some examples you talk about that are actually a little more challenging than that?
Some bacteria can be very resistant to the environment. They can be resistant to the environment of human immune system in terms of replicating intracellularly, replicating inside of human cells as opposed to in the bloodstream, and they can be resistant in the external environment. For instance, there's this fascinating zoonotic disease called Q fever, which was originally sort of simultaneously discovered or almost simultaneously in both Australia and in the U.S., actually in Montana, where I am now. It's caused by a particular form of bacterium called Coxiella burnettii now, if my memory serves me. And this is a bacterium that is relatively resistant to desiccation, to drying in the external environment. It forms not exactly a spore, but a spore-like body, a hard, small body when it passes from one infected victim to another that can spread on the wind. For instance, this particular thing, the Q fever bacterium, replicates pretty vigorously in goats. And it's been a problem on goat farms in the Netherlands. This started causing outbreaks in human cases 6, 7, 8 years ago in the Netherlands. People were getting this mysterious disease, and it was finally diagnosed as Q fever. Where was it coming from? Well, it was coming from goat farms, and not just affecting people who were working on these goat farms where the goats were raised for dairy, but people downwind, 3, 4, 5 kilometers away, because the bacterium, the Q fever bacterium, would cause abortions in goats, and when the goats aborted, these spore-like bodies of the Q fever bug would come pouring out and would spread on the wind, so that communities living downwind of the goat farms were having caseloads of Q fever.
Wow, that got to make it incredibly difficult to trace the origins when something's, out in the wind like that.
It is. It was very puzzling to the health authorities for a while. I spent some time in the Netherlands talking to the people, including one fellow who had been on one of the response teams. And he was sent out to a goat farm. They suspected that this goat farm was an epicenter of the spread of this particular pathogen. So he pulled up in his car, and the wind was blowing, and he parked in the yard outside the big goat barn. And he got out of his car, and then he was about to put on his protective gear, his Tyvek suit and his mask and his goggles. And then he realized, wait a minute, this is ridiculous. I'm already downwind of this goat barn. I've already been exposed. What good is it going to do me to put on my protective gear now? So the point of that is that there's a lot of groping in the dark in the early stages of dealing with a new outbreak, a new zoonotic pathogen spilling over. Scientists don't have any idea at the beginning what it is, how it operates, how it spreads, how it might infect them, and therefore how they should protect themselves. So mistakes are occasionally made in the very early raw stages of research.
You're listening to Skeptically Speaking. I'm here with David Quammen, author of The Song the Dodo, Reluctant Mr. Darwin, and most recently, Spillover, Animal Infections and the Next Human Pandemic. So I guess the big overall question to kind of come back to is why zoonosis? Why spend so much time on this? What are some of the larger lessons that we should be taking away from these cases?
The largest of all lessons is that we humans are part of nature. We're not separate from it or somehow above it. People sometimes talk about, well, this is something that's happening in the natural world. I make the argument near the end of the book that there is no natural world. It's a bad and artificial phrase. There's only the world. And the world is occupied by gorillas and chimpanzees, protists and bacteria and viruses and humans. And the topic of zoonotic disease is a reminder that we're all interconnected. There are now 7 billion of us humans on the planet. We represent the largest biomass of a large-bodied mammal that has ever existed on this planet. We know that from the fossil record. There's never been anything that was as large-bodied as we are, that was as abundant as 7 billion individual members. So what does that mean? That means we represent a huge opportunity for any virus, any bacterium that is adaptive enough, flexible enough to get into a host. We represent a huge opportunity for Darwinian evolutionary success of anything that can get into us and spread among us. So it suggests the need for a bit of humility, a bit of caution, a whole lot of vigilance, for going a little bit more lightly in terms of the way we interact with the rest of the world, all the other species and ecosystems on the planet. And as I say, it's a reminder that we're part of all that. That is the world in which we live.
Are there any sort of personal lessons that you took away, either from any of the cases that you looked at or just generally the places that you visited? Anything that you took away from it?
I suppose some very practical things. I mean, I was already very attuned to this idea, this belief that we're connected to the natural world. We're not separate from it. So that was one of the things that attracted me to the subject. I didn't need to be taught that still again, but I was taught some very basic things like when you're traveling in the tropics, don't eat the monkeys. Be aware that these things are out there without being terrified or paranoid about them. 15 years ago, if you had asked me to spend time in Ebola habitat, I would have said no thanks. That was sort of unthinkable to me. But in the years since, I've spent a lot of time in the same forests where Ebola lives. We still don't know exactly where it lives. We don't know which animal species is its reservoir host. But having spent time in those places and been a little bit careful about what I did or did not disturb and what I did or did not eat, what I did or did not do, I realized that there's nothing magical about these dangerous viruses. They're not preternatural. They're natural creatures that have their ecological ways, their life history strategies, and if you show them a bit of respect and if you're knowledgeable about them, then you can pass through the world without having to be concerned every minute that you're going to get infected with something hideous.
You actually were really, really clear at this, sort of close to the end of the book, this sort of big idea. And you said people, gorillas, horses and pigs, monkeys and chimps, bats and viruses, we're all in this together. Why is it so important to keep that view of the world in mind?
Well, it's important because there's a tendency for us to think that the world belongs to us, that it exists for our pleasure and our use and our disposition. You know, that's an idea that comes out of Judeo-Christian stewardship themes in the Bible, among other places. And I don't mean to be too hard on religion here, but it's an insupportable and disastrous idea to think that the world exists only for human use. We care about humans, we care about human health, we want to feed our children, etc. But there are so many of us now, there are 7 billion of us, that we just cannot go on treating the world as merely resources for the convenience and pleasure as well as well-being and sustenance of humans. We have to realize that there are limits to that. There are limits to how much we can exploit. There are limits to how much we can disrupt, especially now in the 21st century when we're all so interconnected. Because when these bugs get into us, now they can pass around the world in a matter of hours, as the SARS virus did when it was going from Hong Kong to Toronto. And so for the sake of the planet, as well as for our own health, for the sake of leaving behind a place to our children and grandchildren and great-grandchildren that's salubrious and beautiful and interesting and diverse and complex, we need to limit ourselves.
And I think that even came out really clearly when we were talking about the bats, that we're a part of how and why all of this happens. I'm also a teacher, actually. And so I usually try to think about what could be a really key lesson that these sorts of diseases could really, that we would want even children to start to understand. Is there a piece of this that you would say that even students in elementary school science classes should be starting to understand?
I think so. I mean, at the most basic level, and at the level of the wonderful, rich curiosity of young children, I think it's hugely important for them to absorb the lesson, to be offered the lesson that there are no good creatures and bad creatures on this planet. There are just creatures. Some of them are a little bit unfamiliar to us. Some of them may be a little bit spooky to us at first. And whether you're talking about spiders or snakes or scorpions or bats or viruses or bacteria, the fact is they're all creatures that are trying to do what we're trying to do, which is survive, replicate themselves, and succeed in the terms of Darwinian evolution. I'm sure that young kids don't necessarily have to learn about Darwinian evolution and natural selection to understand that much, to understand that these different kinds of critters are just living their lives in their circumstances and trying to make a living. And just as lions make a living in Africa, killing wildebeest and zebras, sometimes viruses and bacteria make a living at the expense of other creatures. Doesn't make them evil, doesn't make them bad, makes them sometimes inconvenient to us, but nothing is perfect on this planet. None of us are going to live forever, and I believe we just have to accept that there is infectious disease, as there is predation and competition and photosynthesis and herbivory. It's one of the basic ecological processes that make the world of planet Earth go around.
Thanks, David. I think that is a really important lesson. And I really appreciate you chatting with me today. Thanks for sharing such a really deeply researched and thoughtful introduction to this world of zoonotic disease.
Oh, you're very welcome, Marie-Claire. Thanks for your depth of interest in the subject.
Oh, it wasn't hard. You can find links to Spillover and David Quammen's other work on our website at skepticallyspeaking.com. So next up, I'll be continuing the disease talk, speaking with health journalist Maryn McKenna.
On the next episode of Skeptically Speaking, we're looking at the explosive geology of volcanoes and how they shape our world both physically and politically. We'll speak to climate researcher Nicholas Klingemann about his book The Year Without Summer, 1816 and the Volcano That Darkened the World and Changed History. And we're joined by geologist Jacob Lowenstern, scientist in charge of the Yellowstone Volcano Observatory, about the massive volcano that drives the geologic activity of the Yellowstone caldera. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm guest host Marie-Claire Shanahan, here today for Desiree Schell. My next guest is health journalist Maryn McKenna. Maryn is a columnist for Scientific American, blogger for Wired, and the author of Superbug, The Fatal Menace of MRSA, and Beating Back the Devil, on the front lines with the disease detectives of the Epidemic Intelligence Service. Welcome, Maryn. Thanks for joining me today.
Oh, thanks for having me.
Tell me a little bit about the virus that is causing some concern in China at the moment.
People may have heard of this as being called H7N9. It's an influenza. It's a strain of influenza. We are always concerned about influenza because it's such an unpredictable virus. Just regular seasonal flu from year to year can be very different in how efficiently it spreads, what kind of seriousness of infection it causes. But we particularly watch new strains of flu when they emerge from animals into the human population because those are the ones that are the least predictable and are most likely to cause severe or widespread disease. So this new flu in China, H7N9, is a bird flu. It jumped from birds. It seems to be associated with poultry, though on the day that we're talking, the World Health Organization has said that not every case actually has an epidemiological link to poultry. So it's a little mysterious. And right now, it's really not clear what's going to happen with this flu, but that hasn't stopped people from being very alarmed by it.
Is there anything about this one in particular that makes it interesting or concerning?
A couple of different things. So the first is that it is new, and the second is that it is clearly a bird flu. But the thing that makes it challenging compared to the bird flu that most people have heard about, which is called H5N1, and was a serious concern back around 2005 to 2007, is that this new flu, H7N9, is what's called a low pathogenic flu, which is to say that when it is in birds, it doesn't necessarily kill them, as opposed to H5N1, which was a high pathogenic, or high path for short flu. That flu was once called chicken Ebola by an international flu expert. That's bad for the chickens, but it's good for us because when birds start dying suddenly from that flu, it's a great indicator of where you should be looking for disease outbreaks in humans. It tells you where the flu is, because this one is a low path flu, which is to say something that doesn't make the birds very sick. It's very hard to know where it is in the bird population or where it is geographically, and so it's hard to know where to start investigations as to how far it's spread. Therefore, it makes it much more difficult to figure out, for instance, where the human cases are. You tend, with any kind of new outbreak like this, to see the most serious cases first because people go for medical care. And so let's say, you have 3 cases that go for medical care and one of them dies. And then you think, oh, we have a mortality rate of 1/3. But what you need to do as you expand the investigation is to look whether there are mild cases where no one goes for medical care or asymptomatic cases where people don't even know they have the flu, and that changes the denominator on the equation that you're working out. With a low-path flu, it's much harder to know where to look for those mild and asymptomatic cases because you don't have that indicator of illness in the bird population to tell you where to go.
And there's been some indication of asymptomatic cases with this particular one, is that right?
There is one case that I heard of in the past couple of days, yes, that got some coverage. A child who was tested, not because they thought that the child had the flu himself necessarily, but because he was one of the person-to-person contacts of a known case, someone who had been ill. I believe this was in Shanghai. And so they tested all the contacts, and this person did turn up positive on a flu assay. And so that makes them think, maybe there are asymptomatic cases. But to my knowledge, that's the only potentially asymptomatic case identified thus far. And I think until you have a few more, it's really hard to draw conclusions.
You mentioned sort of spreading from region to region and knowing. It's difficult with this one to know since it's not very symptomatic in birds. How has this one progressed in terms of moving from region to region compared to other bird flus or other flus like it?
This is all really new. This flu has burst onto the scene, both in disease terms and also really in sort of public interest terms, really rapidly. The first cases were announced in the last day or two of March. So we definitely have less than a month here. And they were identified at first and announced, and this is an important point, by official sources in China, in comparison to some earlier outbreaks in China where unofficial sources announced things first. The Chinese government and its health ministry and so forth actually announced this first. And they were in Shanghai and in several provinces that sort of embrace Shanghai to the west, that kind of make a half moon around the city and its municipal area. So to my knowledge, most of the cases have still been in that ring. It's a pretty wide ring. It's a pretty wide area. But nevertheless, there isn't yet the kind of dissemination all the way across the country or into other parts of South and Southeast Asia that people saw, for instance, 8 years ago when H5N1 started to spread around the world, and it moved out from southern China and was fairly quickly in other Southeast Asian countries.
You mentioned sort of how it's been communicated and how the government has approached sharing their information about this. I spoke earlier with David Quammen about the SARS outbreak, and having lived in Toronto at the time, it was of a lot of interest to me. And we talked a bit about why it was so interesting from a zoonotic disease perspective. But there seems to be an interesting comparison between this one and SARS in terms of communication, what was shared, when it was shared, and how it was shared. Is that right?
That's absolutely true. And I remember covering SARS at the time. The fascinating thing about SARS was that as the West, or rather the rest of the world, not just the West, became aware of SARS in late February, early March 2003, it was discovered then that SARS had actually been burgeoning since the fall of 2002 in southern China. And respiratory illness was building in southern China, and the Chinese government really didn't want that news to come out. In late 2002, a web crawling program that's operated by the government of Canada on behalf of the World Health Organization picked up some chatter, some local chatter in Chinese about respiratory illness, and went to the Chinese government and said, what's going on here? And they said, we're just having a bad flu season, please don't be concerned about it. And it turned out that they were not telling the truth. The way that the story of SARS really broke out to the rest of the world is it's such an object lesson in how information really in a modern wired world cannot be contained. The first alert was carried as a request for information, a question from the audience essentially, on an international mailing list called ProMed Mail. And the way that it got there is just fascinating. The note was placed on ProMed Mail, which is a sort of internationally crowdsourced list, by a guy who had an infectious disease consultancy in the city of Baltimore. He had previously been in the U.S. Navy, and he had lived in Hawaii, and his next-door neighbor was a woman who, years later, in 2003, was a fourth-grade teacher in California, in the Bay Area. This teacher was participating in a teacher's chat room on the net, and often talked to a guy who lived in Guangdong. One night would have been February 8th or 9th, 2003. She got a note from this person whom she knew. She never knew his actual name, who said, have you heard of the terrible illness in my city? People are dying. The hospitals are full. Well, this woman didn't know anything about that, of course, being a teacher, but she sent the note on to her former next-door neighbor, now in Maryland. He sent it on to this list, operated out of Harvard. They put it on ProMed Mail on the morning of February 10th, 2003, and within about 48 hours, the Chinese government confessed to the existence of SARS. It was an object lesson in how you can't contain information information that, as we all used to say, information wants to be free. And it actually changed the conduct of public health forever, because after SARS was over and dealt with, the World Health Organization and the World Health Assembly rewrote the regulations by which everybody conducts public health jointly around the world. They're actually called the International Health Regulations, the IHRs. And for the first time, they enshrined unofficial sources, like reports on the internet, as being of equal weight with the kind of official sources that emerge from ministries of public health.
That is a fascinating story.
It's amazing. And when you hear that story, you can understand why people are looking at China now with skepticism about whether they are really being transparent, because everyone remembers what SARS was like. And there is plenty of hypothesizing that if the Chinese government had just been more forthcoming in the end of 2002 instead of the beginning of 2003, SARS might not have gone around the world in the way it did, might not have appeared in 24 countries, sickened 8,000 people, killed almost 800, paralyzed the city of Toronto twice.
Yeah.
There would have been a very different result. I think responsible sources, the people whom I prefer to listen to, are saying at this point, the Chinese government really did learn its lesson. They really are seeming to be transparent this time. The fact that the first cases of this new flu were announced by official sources, that someone didn't have to leak the news, is a really good example of that.
Yeah, it seems very, very different. You're listening to Skeptically Speaking. I'm here with Maryn McKenna, health journalist and author of Beating Back the Devil, on the front lines with the disease detectives of the Epidemic Intelligence Service. It seems so easily like that communication of SARS it so easily couldn't have happened, or could have been delayed by another 2 days or 3 days or a week. But I am glad to hear that it seems to have changed the way that people really approach this. Even though we're hearing a lot more, do you think there's still a certain amount of caution that we need to take in how we listen to and read about these reports?
So the difference now from 10 years ago when SARS was happening is that 10 years ago there was no Twitter. And, it's not as though the internet didn't exist 10 years ago, obviously, but social media didn't exist in quite the same way. So people were still communicating sort of on bulletin boards and by email and so forth, but the kind of mass conversation of millions of people at the same time that's happening now didn't happen then. What that means to me is that the kind of echo chamber on the internet in which things get misunderstood and blown out of proportion, the echo chamber is so much bigger than it was 10 years ago. And as I've been watching, particularly on Twitter, particularly the social media reports, since the beginning of this new flu, H7N9, I've really been troubled by what I am seeing. That is, some of it's outright speculation. Some of it is people just kind of being troublesome for the fun of it. There's a lot of hypothesizing far in advance of the evidence. I'm not saying that people shouldn't talk. Of course, as a journalist, I have very strong standards about the freedom of information and people's ability to express themselves. But the problem is that most people looking at those social media reports aren't doing a good job of figuring out what sources are really trustworthy. And that means that alarm and panic and kind of generalized concern and misinformation is really swirling around out there with nowhere near enough corrective kind of weighted on the other side.
How do you know in this kind of instance what a trustworthy source is? Like what should people be doing to decide if the things that they're hearing or where they're hearing them from are reliable?
What I want to see people doing is just being much more careful about the identity and credibility of people whom they are consuming news from. And what that means is that you can't take any report at face value. You really need to click through from Twitter or your third-party app and take a look at who is talking. For instance, even though I often have disagreements with them, I trust reports from the World Health Organization, the Centers for Disease Control, the European CDC, because I know they've got multiple layers of scientists who have vetted any scientific report that they put out. I trust people whom I know have been in the flu world for a long time, because flu is a really complex and unpredictable disease. So if you come to flu new, you may make a lot of mistaken assumptions about how it behaves. So there are certain bloggers, Crawford Killian and Michael Costin are two fantastic examples, who have been in this as aggregators since the earliest days of H5 H5N1 10 years ago. I trust reporters who I know have been covering this all the way through. Helen Branswell of the Canadian Press, Declan Butler of Nature, Martin Enserink of Science, they also have been in flu for a long time. And I know there are also people who are in China, who are on the ground and who speak Mandarin or Cantonese and read Chinese, who I know are going to be translating accurately. The big challenge here, of course, is that most of the initial news is occurring in Chinese. Most people who are consuming the news from China don't read Chinese. So they're running things through machine translations, and the machine translations are often not accurate. China has a Twitter equivalent. It's called Weibo. And in order to put things on Weibo, because Weibo is censored in real time, people often speak sort of elusively and metaphorically, and none of that makes it through machine translation. So if you're trying to read Chinese Twitter, you can get things totally wrong. One of the things that I ask people to do, and the week that we're speaking, I've actually been teaching for a week at the University of Wisconsin as their science writer in residence, and so I'm showing this to students in real time, is when someone appears on a post, in a Facebook status update, on a Twitter update, anything like that, I ask them to click through to that person, not just to their Twitter bio, but all the way through to the person's own webpage. Take a look at who they are. Take a look at their publications. If this person is presenting themselves as a flu expert, a scientific expert, but they've never had a single journal publication on flu, or they've only published in the sort of like open access webpage that isn't actually a journal, but is just kind of made to look like one, then they are probably not the most trustworthy source. Go for somebody who actually looks like they understand the nuances of this very complicated organism.
All of that advice is well taken when trying to make sense of any scientific news, too. So you mentioned the World Health Organization, actually, and they've been using Twitter quite extensively in regards to sharing information about this particular flu. Do you think efforts like that are helpful to the general reader who's trying to get information?
It was really fascinating to me that after this had been burgeoning for a couple of days, the WHO came out and said, we are going to release our newest case counts on Twitter first, and then we will back them up with more detail on a dedicated webpage that we have built just for H7N9. That would have been unusual for any official sort of organ of any government. It's particularly unusual if you happen to know the WHO or have followed it for a while, because up until quite recently, they really were kind of lagging in their communication and social media strategies. Their website was hard to navigate, and their Twitter voice was almost non-existent, so that the fact that they decided to be so sort of forward-facing, to go to Twitter first and to make the news on their website really easy to find, that's a particularly big leap for them, and I really applaud it. What is especially interesting about what they did with regard to Twitter is that after they had been publishing their news first on Twitter for a couple of days, they actually came back and said, we may change our Twitter strategy. And they announced this on Twitter, of course. They said, we may not keep reporting cases incrementally here. We may instead start talking about broad trends. I have not had an opportunity to discuss that change in strategy yet with them, but I think what we were hearing, and this is certainly what some other folks saw in this, such as the excellent reporters at CIDRAP, CIDRAP at the University of Minnesota, the WHO began to be concerned that by putting those numbers out into the echo chamber and having them just repeated millions of times, that they were accidentally ratcheting up concern. One of the things that's problematic in Twitter is that because people consume it so opportunistically, you're not always on Twitter all the time, sometimes you dip back into the stream in a kind of random manner, and so you might get someone pushing forward, RTing an update that's actually hours or days old, and it really contributes to the confusion, the sort of swirl of, well, what really is the newest news? And my sense is, and CIDRAP's sense was that the WHO was kind of trying to damp down that effect a bit.
But still trying to be fairly open with discussing what was going on.
Yeah, depending on how this epidemic goes, if it doesn't turn out to be a pandemic, which will cause us to worry about quite different things, looking back on the communication strategies in this is going to be a really, really interesting exercise.
So if there's one last thing that you would want people to take away from how to make sense of this as it progresses in the coming probably weeks and months, what would that be?
I really want average consumers of the news, everyday people who are interested in what's going on, to do what reporters like me are supposed to do. I always hate to quote him, but it's kind of the perfect advice. I go back to Ronald Reagan, who, when he was talking about nuclear strategies with the then Soviet Union, said, "Trust but verify." It's excellent advice for anyone who's trying to figure out what's going on in the swirl of a new epidemic. Believe that you have identified good sources, but always verify whether they are really good sources. And if you can't verify it, maybe reconsider your trust.
Thanks. I wasn't expecting a Ronald Reagan quote, but it does actually make a lot of sense. Thanks so much, Maryn, for joining us today.
Thanks for having me.
You can find links to the important writing done by David Quammen and Maryn McKenna on our website at skepticallyspeaking.com. While you're there, click the links to Facebook, Twitter, and Google+, so you can keep up with show news, and to iTunes, where you can subscribe to our program or listen to past episodes. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is, 'cause we're skeptically speaking.
Skeptically Speaking is produced and distributed by Suburban Panic Media. Our guest coordinators are Rochelle Saunders and Ed Haynes. Our social media manager is Chelsea Butler. Helen Quivalon is our publications coordinator. Ryan Bromsgrove is our production manager and assistant editor. Josh Witten is our researcher. The show is edited by K.O. Myers. Our theme song was written and recorded by AOK. And I'm your host, Desiree Shell.